Now that the receive circuitry is complete, the next stage is to build up the transmit mixer. And the first step of that is to build up the circuitry that supplies plus 8 volts on transmit on key down, and that's handled by Q4. Basically, Q4 is a PNP transistor that key down simply grounds the base of the transistor, and that connects the plus 8 volts to the plus 8 volts TX line. So the transmit mixer itself occupies this section of the PCB. It's an alpha SA602. There's a place for a 4.915 megahertz crystal here and some other associated circuitry. On the band module, there are some band-specific parts of that circuitry too, and they consist of these two inductors, these two variable capacitors, and I'll cover that in a bit later when I get to the actual circuitry. So drilling into the circuitry itself, and I've got a blow up of the transmit mixer here itself. So on the transmit mixer, it takes as input the signal from the PMO, mixes it with this 4.915 megahertz intermediate frequency, and then produces the usual mixer products out here, runs it through this bandpass filter, and then finally through this buffer FET here, and then from there to the PA. So taking our example of, let's say I wanted to transmit on 14 megahertz, the PMO for 14 megahertz would be 18.915 megahertz, as we discussed in the previous example. So we get 18.915 megahertz in here. The oscillator here is running at 4.915 megahertz, so those two mixed together, again, produce a variety of mixed products. And what we're looking up for is this frequency minus this frequency. So the variety of mixer products will come out of pin 5 here through the bandpass filter. And this is a bandpass filter specifically geared around 14 megahertz. And so after the mix of 18.915 and 4.915, we'll get 14 megahertz out of here and then through this buffer JFET here. So the bandpass filter itself consists of two inductors, both at 2.9 microhenries, and that they're built up as 27 turns around T37 toroids. And then that is tuned by two variable capacitors here, both 50 picofarad capacitors. So to test this, it's pretty simple. Well, I'll hook up the oscilloscope to the output here, and I should get a clean 14 megahertz signal out of the JFET. So I'll build that circuitry up, and then we'll go through the circuit on the PCB and go through the testing. So the transmit mixer is complete, at least from a circuitry perspective anyway, including that bandpass filter that I mentioned before for the 20 meter band. Just panning up, you can see there's my probe there. I'm actually probing the source of the JFET at Q5, and as you can see, there's a stable 14 megahertz signal there. As I adjust it slightly, you can see that the frequency will change. So now we're up to 14.0272, 273 megahertz. So just to demonstrate the bandpass filter on the transmit mixer. So as I mentioned in the previous video, there's actually two 50 picofarad trimmers that are used to peak the bandpass filter. So you can see as I adjust those, the signal rises and falls there. So that basically, we're looking for that peak there, and it's got a very sharp peak on both of those. All is not well, however. So from 14.0 to up to about 14 you can see I'm slowly raising the frequency there. Now we're up to 14.055. But at a certain point here, what you'll see is up to 14.064, still going well. So you can see the signal starts to destabilize. So we're up at 14.076 megahertz, and already the signal's starting to destabilize, and you can see as I go further, signal completely distorts. So not quite sure what's going on there. I thought initially there might be something to do with this short piece of wire that I had connecting kind of the input of the receiver to the antenna. I got rid of that and it didn't really affect anything there, so that wasn't it. One of the other things I'm going to try also, I was, as you can see, I alluded to this in a previous video, there's two transistors here that are both turned on and bring the receive path to ground when the transmit is turned on. So I'm going to install both of these guys here and see if that fixes the problem. Perhaps there is some stray RF that's being picked up when the receive path is supposed to be completely drawn to ground. So I'll definitely try that. One of the other interesting things also is I've also noticed that if I probe anywhere along the PMO line, and I'll have to look closely to see that, you can see that the signal completely clears up. So again, not quite sure what's causing that. All I've got here, let me just pan back to the. All I've got there is a metallic probe, in this case my knife, connected to just touching the PMO line. You can see from the scope we've got a sort of a crystal clear signal. So I'm not quite sure what to do with that information. Obviously there's some instability going on here, so I'm going to have to trace it down. But what I'll do is I'll post this video on, and then I'll continue my troubleshooting, and we'll see what happens. So some progress, a little bit of a problem. This is kind of the first problem I've had on this build so far. So we'll see where that goes. I guess that's half the fun, is the troubleshooting. Anyway, I'm going to post this now, and I'll continue my troubleshooting. Well, just a quick update. I did install the two transistors, Q1 and Q2, that will act to pull the receive path to ground when the transmit's on. Fortunately, that didn't do anything. Obviously, I've still got the stable signal down low, but as soon as I increase the frequency, it starts to distort. So again, not quite sure what's going on. I mean, the signal itself on the it looks kind of a little bit like AM. So if I increase the time scale here, you can see there's sort of an AM flavor to some of it. Yeah, I'm not quite getting it now, but let me just. You can see there's definitely some modulation of that signal going on top of the 14 megahertz signal. So not quite sure where it would be coming from. Anyway, more experimentation to come. I'm gonna, obviously put this video on. I'm going to continue troubleshooting. What I might do is potentially build up the kind of the next stage, which is the parts of the preamp. There's a transistor which is at the start of the preamp. What I might try and do is build that up and see if anything happens. So that will be in a subsequent video though. So all right, that's all for now. Catch you later.